Okay. That should work.
Yeah.
So let's look at the paper. Sorry, was set for a moment. Yeah. You already. Yeah.
Yes. So
No
this
idea
is
about this paper. Burni was the one who wanted to read it.
yeah.
So.
This seems to be steering vector with like an arbitrary verifiable domains. They tested it in math, so question is if it works outside of math. But yeah, you just need successful and unsuccessful generations and construct steering vectors from that, and it works apparently. Maybe you can zoom it a bit more for the live stream to pick it up more.
Okay. Like this.
Yeah, I think so.
Let me just quickly check that the stream is working. Okay.
Oh, I see on the stream OBS instead of Discord.
Oh, wait, what? Oh, yeah. Good call.
Okay.
Also, the audio seems to be working, so yeah, it was only that. Yeah. So that's it.
Yes.
So, okay, what is this out? This time optimization remains in practical schedule productivity inference cons. This techniques like iterative refinement and multi-step equations can require dimensional compute per query and standard decoded. Latent space test time optimization methods like latent thick often amortized latent theory. This collapses iterative optimization into a single offline computed vector applied at constant cost to the inference. Our computers the mean difference in this direction to calibrate the model hit representations. When the code takes a one from the test manifold. Oh, people are leaving. I don't know. Anyway, yeah. What was it? Computers the mean difference between hidden states. Okay. And how this method bus to assets. Okay. Yeah, it's also estimated. I don't think I understand it yet, but okay. Across schemes and math benchmarks, the iterative methods. Okay, so it's So this is trying to seems to be referring to some methods that are more like using optimization to find steering vectors, right? Rather than doing the typical difference in activation thing.
I think it is the difference now, but it's just taking the correct and incorrect outputs. Wait, let me reread it.
No, I just think latent seek. This latent seems to be something like optimization, and then here it's
Yeah, okay, those are the different one. Yeah. Okay.
they should tend to
But yeah,
replace
there are
latent
also
with specific.
there are also like methods where you basically use reinforcement learning to train the steering vectors instead, and that works
Yeah.
on math.
The thing with those methods is that, like, for more Mech Interp things, I would worry how much. Like, that tells you less about the model because it's. You might be optimizing. Like, it with the activation, you are in some sense keeping things in the in distribution for the model. Here you could be breaking the model in weird ways, right?
Hmm. Yeah, the steering vectors aren't derived from the activations if you use the reinforcement learning, for instance. But I think in this case, in this concrete paper, it is derived.
Yeah.
Uh,
Let's see what they do. Okay, so test time optimization methods. Okay, more computer standard recording. Yeah, test optimization is the gradient. I guess is the yeah. The test space methods. Okay. Amortized Latent steering. Model outputs. Rather than iteratively optimizing during inference. As pre-computed steering directions by analyzing the causal relationship between hidden relations and relations. Yeah, so this is more like the different kind of methods, but it's yeah.
yeah, I think this graph is a nice summary of the whole thing. You take the input prompts,
Yeah, you
generate
get model
the
responses.
responses.
Yeah.
You partition it into correct and incorrect depending on the output. Then you basically do the steering vector thing.
Yeah, the mean steering vector, typical mean steering vector thing. Yeah.
Yeah, but here you take the correct one and incorrect ones for and like that's math in this case, and it can be anything. That has a like correct incorrect label.
Yeah.
Output pre-computed v.
E is this the correct minus the correct.
Oh yeah, I see. Okay.
Okay, so cosine similarity check. So they do cosine similarity check with
Yeah, between the hidden
HTTP.
state and the mean difference, like the correctness direction, you could say.
Okay, yeah, so this is for the vector you're actually applying it on. You have the steering vector, you
Yeah,
get
yeah,
it in the usual way, and then you check the cosine similarity, and
yeah. And if it's too far away, then you basically nudge it back to the correctness direction, and if it's not too far away, already on the correctness direction, then you don't update. That's my understanding.
okay, so this is more like the normal steering method, but instead of just adding the B to the model, you are trying to reduce the cosine similarity with B, right?
Yeah, yeah, yeah. You
Eh,
try to nudge it back. You try to nudge it back to the correctness direction.
I think this is going to have interesting difference with normal steering. That so normally steering is like you are adding to it, and here you are reduce. But no, there you are anyway. Okay, never mind.
You're still adding in
You're
the
still
nudge.
adding. You're just doing
Also,
adding
also
only if
you
the cosine similarity. Isn't this just normal steering but only when the cosine similarity is different?
yeah. Plus, it's also you compute the steering vector using the correct minus incorrect, which I think
Never.
I thought that's normal, but apparently that's not. I haven't really seen it anywhere else. Maybe the reason why it's not anywhere else is that you have to do this nudging instead of updating every time. Otherwise, you just break
But
it.
I mean, what? Why is correct versus incorrect? Like, for example, why is this not an example, like the steering vector for emotions, not an example of this? Without the cosine
Uh,
thing, I mean.
uh, there's no correct and incorrect emotion. You have just like
Yeah, but you have things with the emotion and without the emotion, right?
yeah.
Like,
Well, you
why
could
is
say that's
this
the
not
correct incorrect. Yeah,
a kind of abstract label thing where, yeah, you could use it?
like
Like,
the thing here, as far as I understand, like if you say yeah, this is the correct emotion that we want, then this is not. This is like humans have to label it or LLMs, but here you auto label it. It's because it's math, so it's like you have a symbolic verification signal instead of using LLM or human to label if it's correct
wait,
or not.
have people really not done any steering
I,
with
I
that?
I thought it's more common, but like I was trying to look for a paper that did exactly like this correct mathematical solution minus incorrect mathematical
Uh,
solutions. I couldn't find anything. Like only this
I mean,
paper I could
I
find.
was doing the
I,
vibe coding steering stuff, and was having ideas like this the other day, but like, it's. I mean,
yeah,
I ended
I
doing
also
the
had
gradient
yeah
thing, but I guess I guess I just had, the models were tiny, but uh, I could have. It doesn't feel like it would have been that weird to do this. But yeah,
yeah. It seems obvious, but
but if
apparently I
nobody
couldn't
does
find
the obvious
anything.
thing, then great. Somebody had to do it.
Maybe the reason why no one did it because people didn't think about the cosine similarity check, and that's what you need to actually make it work.
Is that
Maybe.
true? I don't know. Can you
Yeah,
not, like this seems like it will help in that if the thing is already correct, you should. Okay, I guess I can see some examples where it wouldn't work, right? Where if it's something where the model sometimes gets the correct answer, you wouldn't. If you want to improve performance on something, you don't want to do steering when it's already getting the right answer, right? So
yeah.
I guess that makes sense. Like the this the guys, I wonder what happens on text where the model is already happy or whatever if you steer for happiness. It probably becomes weirder. Uh,
Hmm.
and yeah.
Yeah, you could apply there. That's correct. That's true.
Oh, wait a moment.
Okay.
Anyway, uh, yeah. What was I saying?
Also, I'm not
Um,
sure. They say greedy chain of thought and self consistency. Is that baselines? I wonder if that's the steering vector for chain of thought and self consistency. Um, which is another one that's like, well, I'm not sure if this is the same one, but it's like you take like if getting a math result without any reasoning, getting a math result with all of reasoning, and then you subtract, and this way you get a chain of thought vector basically. Um, this
yeah.
is what's done as well. It seems to work. There are a lot of yeah. Basically, I tried to like, like we listed so many steering vector ideas, and I was like, okay, what exists? So I was like asking LLMs like, show me papers that already implemented it, and they found like this one, for example.
Mm. But do you know what the greedy chain of thought is?
I'm not sure if this is the one, but there is there is a steering vector that you construct by you take LLM generating a math solution without any reasoning, and then LLM generating a math solution with long reasoning, and then you subtract it, and that way you get chain of thought vector. I'm not sure if this is the same one, though. So we will have to look into the details.
Okay. Uh,
Drifts away when decoding drifts away from the success manifold. I wonder if that's actually what's happening. That's pretty interesting that there's such a thing of like correctness direction. I mean, it makes sense, kinda.
uh,
And apparently it's matching the iterative. Yeah, I don't know how the latent seek works. It's optimization based. Like I found also like ways of in order to create like training the steering vector from scratch using reinforcement learning. That's also a thing that seems to work for math at least. Also, I wonder how much all these steering vector constructions can help in sparse autoencoders, all these um, nuances that are done here. But I think I wanna play with this one because it seems to be very like easy. Like there's nothing complicated about it and it just works. And you can use it on arbitrary verifiable domain basically. That's my hypothesis. Right now it works on math.
uh,
Efficiency, let's see.
I mean, usually then it should be able to do. I don't know the. I mean, the causal similarity check is nice, but I don't think it's always necessary. But yeah, I think just doing this seems like very easy, and it should go for all kind of things.
Say it again.
Doing this, it seems like it should be easy and should work for all kind of things.
Yeah, that's like classic stuff. Yeah, grounded in some
Yeah,
verifications. You know,
that's part
I'm
of why.
surprised this is not
I
more
feel like we
common.
need to do a project or something like trying a lot of different kinds of steering and seeing which ones work.
Yeah, yeah. Like after the I'm like when we try to use LLMs to do it automatically, I don't trust any of it, and this I wanna take this and use it with my own brain, my own hands, and
Yeah.
just write it myself because I just hate the fact that every time I generate something with LLM, I am paralyzed because I cannot be bothered with checking if it's
Yeah.
slop or not. uh,
I mean, I
yeah, but
think I started more into
but
the.
this should be easy. Like technically here the verification signal is it's better on benchmarks. So if you have a verifiable domain, so this should be automatable. But I
I
might,
think
yeah,
for some
whatever, I
things it
might
might
dream.
be better to just use, not use cloud code and just use the web and slowly get it, like still let it write the code, but do it slowly and actually reading it before and forcing yourself to copy paste it into Visual Studio Code after reading it.
That's true.
Maybe
That
this
creates some like friction.
ideally you will like force yourself to write it yourself by hand, but that's maybe too much. But for K
Yeah,
things, maybe you should. But before, if that's too much, it still feels like too much. At least actually,
yeah. But yeah, like I think here they have some baselines. These baselines can be all used and like what I was thinking here is like I don't know if you could like have some benchmark which would be like aligned, misaligned. I think there are benchmarks like this. Then like you could use this basically like incorrect, correct, aligned, misaligned, or something like that, and see if that works on that benchmark. Um, whatever Anthropic have, I think. Anthropic has something like that. Also, like, Anthropic just released, also that's a thing we can look at next week. They released, like, automated safety researcher that's apparently superhuman, according to Anthropic. I'm not sure how much I trust that. I'm not sure how much it's also public, like, what's all public. I just seen a title.
Can you
So this is just another way of taking the mean for successful and incorrect and then computing the vector. But
The
how do
thing
they change
is,
it?
just another. The fact I try to look everywhere in the steering vector literature. Basically, no one. I couldn't find anyone that says that was like correct minus incorrect. Like everyone was like, here's like emotion. Like I don't know. Here's activations with all of chain of thought and no chain of thought. Here's activations with like I don't know angry and other emotions and so on. But like no one was like, here's correct math benchmarks. These are incorrect math benchmarks. Only this paper. And then everything else that tried to do this kinds of stuff on Ma was like training a reinforcement learning, using reinforcement learning the steering vector, for example. That's another thing.
Oh, I
Or
see. I
like
see.
the chain of thought thing. Like this is the only paper I could find using LLM search. Maybe it's not perfect. I just prompted all LLMs in parallel. Like
It
find
feels
me
similar to the
papers.
correctness probes,
How do they work? Can you say?
or like just simply just probing on incorrect versus not incorrect. You could just simply make those simple probes. Seems similar to that.
Yeah, that seems relevant as well.
Yeah.
But it seems like
Yeah,
this is
yeah,
like
I think
another
that
way to
works.
do it, but this is the activation steering method of doing it, I guess.
Yeah,
I
like-
But
think
it
it's,
makes
it's not like the same in that if you have this correct and incorrect thing, but if you are doing a probe, you are trying to figure out if you can classify, like, if in some sense the information about if the thing is incorrect or correct is linearly represented on the inside the model, right?
Hmm.
And here you are the is correct versus incorrect thing is coming from outside, right? Is you are trying to steer it towards the correct thing.
I feel like this
Yeah.
has been done before, but I don't know what paper.
I couldn't find to give like I wanna see when it was done before. This is the only paper, and I'm surprised. Like I thought it's so obvious to do this.
I feel like other people might have done it, but they didn't like I guess like formalize it as like a new method, I guess. That's the gut instinct I have from this method. Like people use this
Like-
probably.
I explicitly prompted all LLMs. Find me a research paper which you tried to like increase performance on math benchmarks using steering vectors with incorrect minus correct like activations.
But this
I-
makes I feel like somebody done this. People who already done this. It's probably just they did never actually labeled it a new technique because they didn't realize it wasn't
Or
done
maybe
for
there
more.
was a
This feels like something like people
paper.
do with their like small experiments, but they never actually like formalized it.
Yeah, I couldn't find. Yeah.
Maybe there is something more for truth, right? Trying to steer for make the model more truthful, which is kind of related, or could be seen as an example of the same thing.
Yeah, if you
and
had
that
some
maybe your
evaluation
search
for
wouldn't
truth.
have found that. Also, by the way, also it's technically also there is also a bit another bit which is the cosine similarity thing, but that's just they calculate the cosine similarity with the vector and they only steer if it's very different.
Yeah. And with some threshold.
Yeah, so which makes sense. It's just that's to avoid steering too much when the thing is already correct.
Yeah. I wonder how latent seek works. It sounds like something from DeepSeek.
It's nice how this paper is not as long as the other one, so you probably could finish on time.
Yeah, it's like four pages, I think, or
Yeah.
6.
We have the one of the authors on the Discord, but they didn't respond when Alex pinged them. So
Mm-hmm.
yeah. Anyway, let's keep looking at this.
And this is interesting. This is labeled as test time optimization. No. What is this labeled as? Like, there's test time training. There's as a paradigm. This is the latent seek is test time optimization, apparently.
Yeah, I mean, I guess that just means they do optimization. There's your only inference they do the activations.
Yeah. So this is like, I mean, you have to train the steering vector in the first place.
Yeah.
Yeah. I wonder how related like LoRa's and steering vectors are actually. I wonder how.
What was coconut? Because I do.
Isn't that the latent paper? No.
Like I definitely remembered coconut, but I don't remember.
Yeah, continuous. Yeah, latent. That's the continuous paper. It's like.
Okay,
I'm not
yeah.
sure how exactly coconut works, but yeah, it's in this paradigm.
I'm confused because this seems like a different kind of thing, right? Showing continuous latent space. Isn't that like
linear intervention methods? How is it a linear intervention method?
Wasn't coconut the neuralist kind of thing, right? It was.
Yeah, it is.
I don't know what that has to do with linear intervention methods.
I'm actually also confused. Maybe it's hallucinating.
Like what?
Maybe it's hallucinating.
I'll ask Claude later too.
No. Oh, wait. Coconut is continuous chain of thought. Last hidden space of the representation of the reasoning space. No, that's just latent architecture. Instead of instead of like you just loop through the layers continuously without using the unembedding layer. So you take the output and put it as an input again to the first layer instead of throwing the output through the unembedding layer. Yeah, I'm not sure how it's a linear intervention method. It is not a linear. What? Smells hallucinated to me. If anyone here knows, you can also say stuff. By the way.
Yeah. Also, in general, to.
Yeah.
I feel like.
Oh, didn't hear you if you. I already.
Yeah, you mute. You said yeah.
Oh, I was just gonna say, I don't know. It seems kind of half-baked as far as the preprint goes. I'd honestly argue, like, I don't know, like, at the very least, you could try maybe doing the linear discriminant analysis, like whitening it with the covariance matrices, which was something that was done in like 2024 with Marx and Tegmark. Because I feel like that, I mean, that's what this is kind of in the realm of, right?
Yeah.
Can you link that? What you're talking about?
Oh yeah, I can link it. It's
or
because that one is
also
also. It's just the geometry of truth paper. You remember that one?
I haven't read it, so I don't know.
Well, because if you're thinking about like correct or incorrect, of course, like this, this paper is like correct versus incorrect responses, like in terms of performance on a specific data set. But I feel like at the very that's like one way of doing it, but like here I think they make a pretty convincing argument that at least, or a testable argument that like trying to remove some of the covariation that occurs with that might be helpful. So I just feel like I guess it's just I feel like their ablations aren't very complete.
And yeah, also this seems the kind of it's the same kind of thing as the does the truth, the geometry of truth paper, in that
Training
like
probe.
that's like true or false statements is the same kind of thing as correct or incorrect, as correct or incorrect, right?
But from probes, you cannot. Can you construct steering vectors from probes though? That's just a linear classifier on the activations, no? A logistic regression. You cannot
Yeah.
construct steering from that, no?
But I think they do. I mean, you can, right? You if you have a probe, you can do steering, but it's not. Yeah, it's not the same method. So. Like you can take the probe and put the the reverse thing where you put the thing that makes the probe high.
Okay. Yeah, I see. I wonder how does that compare? Yeah, like the Claude is saying that the coconut reference is nonsense.
I wonder how.
Where's the coconut reference here? I don't see it.
Oh,
Where's
correlated
coconut?
expression.
Oh, this is not related at all. Like they clearly over here, this is not latent reasoning.
Okay.
Look at the coconut GitHub. You can see how they use the KV cache to steer it.
I wonder
Is
what
there steering
happened
in
to this
coconut? Or what do you say?
Coconut,
Victor?
I don't think it's a linear steering method, or maybe it's
Yeah,
another
yeah.
thing.
Coconut is what
Coconut.
does an architecture for like the using chain of thought, like putting vectors on the chain of thought. So,
Yeah. Instead of unembedding each autoregressive step, you just take the last layer to the first layer again.
yeah.
So
We
never
did that paper
leaving the latent space. Yeah.
some weeks ago. So I wonder how that got there, but okay.
Maybe they wanted something else that's like it is using chain of thought. What is their baseline? Let's see if they say coconut.
Yeah, I mean that makes me doubt a lot of trust less in the paper
No.
in general, but okay.
It's just mentioned once in the
But I was there with.
Isn't LAAs also like some disorder? Okay, it's amyotrophic lateral sclerosis. But I think it's overall a good paper because it's the only paper I found that uses correct incorrect on math dataset to construct a steering vector.
It's not the most.
Like it's an obvious paper that for some reason I couldn't find anywhere else. That's my feeling.
Still. I mean, if the only problem is they cite things wrong or something that's fixable in the like maybe they'll publish later and they were roasted by reviewers and will fix a lot of things. But it just seems weird how that, like, if it doesn't have anything. Maybe I'm missing some way they are connected or something, but it feels kind of random that they put that in.
Yeah, same.
Hello, Zappers. Velocity intervention frequency. Yeah. It's a typical thing where you need to put some threshold for steering. Wait, maybe we should at some point go back and reread For the reading group, I mean old papers like the Geometric Curve of Truth, the one that are important.
Yeah, I feel like that's a good
gonna
paper to look
extract-
at, but I feel like you could look at it without going to doing a reading group.
That's also
I'm
true.
gonna just extract the method using Claude.
Anyway, experimental results. They evaluate on this. Yeah, on the math stuff. And this is the typical thing where they show different methods, and their method is going to be has higher numbers, which can be because it's actually better, or can be because the image amplification is
The vibe we get from this
Cherry picking
paper,
method.
I feel like this paper, I honestly, like, with how, like, they did refer to other papers, I don't know if this is not hallucinated.
Okay, that's true.
I guess, like, proven.
I mean, there's a code base, so we can like test everything with code
That's
base.
true.
True. But I don't buy
But
it
only
being
matters
better than
if we
everything.
actually do that.
Like, it seems like it should obviously work. So
Yeah, I mean, I think it
like
should
many
work.
things, like many things should obviously work, and then they don't.
ஒன்னா வித்தியா முடிச்சுட்டேன் வேலை முடிச்சுட்டேன் வேலை முடிச்சுட்டேன் அவ்வளவுதான்.
Bonai, either you're trying to say something or you're oh,
Yeah,
he left. Okay.
I feel like also you should, they should do this kind. They should compare with doing a steering with without the cosine similarity thing.
Yeah, like that's also like that's like the first thing I would try. Why is it not tried? Or at least compared to.
Okay.
Why is there no paper doing this? Maybe because it doesn't work and you need the cosine similarity check. I don't know.
Maybe, or like they got slightly better numbers.
Yeah.
Or maybe they were by coding it and Claude decided to
Maybe
do that.
it looked too. Yeah, or maybe it looks too similar to other work. So in order to not
Yeah,
look too similar, that might be actually the reason. I think maybe.
Yeah, I mean, I not even, yeah, like I'm not sure how the method is actually nowhere, right? I don't think it's bad. Like, even if it's not, I don't think it's bad to do a paper on. We did the steering on to math, right? That doesn't have to be a novel method. You
Yeah.
can just test normal steering on to see if it improves on math data sets. If nobody has actually done that, maybe there is something who has done that and we don't know. I think that's an interesting paper. Maybe putting as a new technique is a bit of a stretch. What did you say about steering? Sorry, I'm not sure what I said a bunch of things in the last few minutes and I don't know what exactly. Oh, okay. So I guess I'll repeat. So what I'm saying is, okay. So this is like, without the cosine similarity thing, this is the normal steering technique of taking examples with the thing and examples without the thing, and taking the difference just applied to making comparing with getting the right response or not on math things, math examples. So yeah, so I think it's interesting to see. It's not. It's a paper that's okay to exist, and it's not bullshit to try that on math, because I don't. If unless someone else has already done it before, but it's I think it's mighty interesting to see, like, if it does work to improve on math. But it seems a bit meh to call it a new technique. I guess the cosine similarity is maybe new, I don't know how much it actually helps. It probably don't help a bit, but it's framing in a way where it feels like the whole thing is.
It just seems like conditional steering. Like if this, it just checks if the steering's already applied. I guess it's near the correct direction, and then if it is, it doesn't apply.
Yeah, but
That's
has
basically
someone
like
already
insight.
done that. If not, at least that's an interesting thing to add. So, but
It's not necessary. Yeah, it's not that
I
interesting.
should also work for other steering methods, but like for other steering
Yeah.
methods. But I will want to see if that part actually helps, right? So if they frame the paper as we also, you know, as a thing they added, like we also thought of adding you know, this cosine similarity gating with steering and improve the performance, and they have compared with the wait, maybe I complaining too much and there is ablation studies and maybe they did ablate that. Let me read this before I keep complaining. But yeah, steering strength, gated variant. So wait, I kind of skipped the gated variant. What is the
Thing about it being a valid or not valid JSON, but that's kind of confusing.
Yeah, I think. Like I guess when you do on math, you need valid JSON output in the result. So if you don't do that, then you can.
But isn't that
When DeepSeek is doing reinforcement learning from variable rewards, there is also like something like this.
yeah, okay, that's a thing. That seems like a
For
very
math.
specific method, but I guess it's a new thing. But yeah, no, okay, it's that is not nothing related to the thing I'm interested in. With like, does this cosine, how much does that cosine similarity thing is useful, and how much is just put there so it's more different from the previous literature?
This paper doesn't seem new in like most ways. It just feels like you're just reframing something that already exists and trying to reframe it.
I mean, I mean, using the framing using the old method on math datasets could be an interesting paper. I don't think people have to. All the papers have to be.
I guess on math datasets specifically, but like
just
I
framing
never
around here.
seen. I haven't seen the cosine similarity thing though. That seems new.
Yeah. But if they have framed it down as their contribution, they could have. Okay, let me read the exclamation stories in case they did check that. But
you know what would be cool would be maybe trying to scale using that cosine similarity. Like if you could like, you know, programmable because in a lot of these steering papers they just, you know, they always do hyperparameter sweeps over the alpha value. But if you could
yeah, that seems like a cool idea, yeah. Like just increase it the more different it is from the
I think they here they try different alpha values here.
Yeah, no,
in
but
the
no, but
table.
what he means is to change the alpha values depending on the cosine similarity with the vector.
That's a good idea. I don't think that was ever done. That's actually a good idea.
I mean, we could try it, but I mean, I will try first. How much? Like, maybe there is something we could try a few people on the server and somewhere.
No, this is probably like something like people could get done in like a week, like a few days.
Or
somebody
a
actually
or something. Like, try, but you will have to do first. Before that, test if ablating the cosine similarity thing at all helps, right? Check with the normal steering baseline, which they didn't test.
Yeah, this is not grounded at all.
But okay, what is the okay? So they try different alphas, which makes sense. By the way, I'm curious the thing. Is it always better than the other method? Not always. Okay, yeah, that makes more sense. Kind of respect. I wonder how much
it seems like on the Yeah, on the GS M8K, it seems to be worse.
Also, the gate thing doesn't work. This is for some reason, which is funny, right?
Wait, what?
On math? Seriously, it doesn't work?
Yeah, I see. Why is accuracy just 3 pre? Wait, what?
Is the
Why is there such a big jump in accuracy?
Why? Why it's only the gated thing is only on the one prompt and not the other? It's because only one prompt that like generates JSON or something. Okay, yeah, it's JSON step by step in our version. The second is JSON. Yeah, so they only do it on the second. Yeah, for some reason the gated thing doesn't completely breaks on this.
But it doesn't break on the other one.
Yeah,
Okay.
I don't know what's going on with that. It doesn't even help that much.
Yeah.
So, and yeah, they're doing the time. I wonder how much this is. They tried to see if it was better, and they realized it was not always better, and then they added the time thing. I know, I mean, it is, I guess, motivated. Like the gradient is less efficient or whatever, but still.
Yeah, but why is it more efficient only on the one benchmark and not on the other one? Why is it so? The gap is so big. 100% and then nothing. That's weird.
Primary improves performance by resolving ambiguity when the model encodes multiple competitive reasoning paths. During complex reasoning, the language models might explore several. I mean, how much? Yeah, correct reasoning. Correct reasoning. Typical. I feel like this is saying nothing, but okay.
Well, this is not saying anything, and there's no latent reasoning model ever in this, not in this paper. I guess from what they're saying.
With correct outputs.
I think this is not too latent reasoning. This is more like if you map the space of chain of thought, you know, you get all these different clusters that some people mapped out. So the steering vector could possibly like steer it towards the correctness clusters.
I mean,
maybe.
But I feel like this is saying, this is just saying with extra, in a fancy way that steering makes the model act more like the model activations be more like they are when they give correct answers, right?
Towards the
But isn't
correctness
this
manifold.
assuming that like the correctness is like, I guess, like maybe a direction? Is really correctness a single direction? What if like correctness for math or correctness for like a reasoning task is different?
That's
a good question.
I mean,
if we do this, like we can't just brute force correct versus incorrect. Because that's assuming all the questions in the sample set like have the same direction from incorrect to correct. But you have to first test that.
Did
Yeah.
they test between data sets?
Well, like for all I know, like the correct versus incorrect here could just be like it only works for math or this specific data set, or maybe only for a few questions.
Yeah, this could be correctness in the specific data set direction.
I think even if there is some correctness direction that it's more general, like the problem is you're probably also going to have problems in that if you are this kind of method, you are only like you're getting confounders in that you take the difference, but both the correct and incorrect examples are from math. So they are going to have the mean is. I guess it's the difference. Yeah, no, I guess no, I'm wrong. Because if you take the difference, both are from math, so they're going to be the same. So you're going to remove the math stuff. But still, I guess you could get something for like the kind of problems that are hard for in the dataset have some feature, and you only get that feature.
Like this hypothesis could be tested by running it on non-math thing that has correctness. And seeing if the steering vector generalizes, basically.
Yeah.
But yeah, they probably have to test if this correctness direction is robust first.
Okay. Oh, so
Yeah,
there
try
is
on
not
other data
much more
sets.
about this, but I'm curious about on this paper. So I'm curious about not related to paper, what the chain of thought thing is, like the other baselines. Also, maybe the latent thing is interesting, but I think it's more interesting. But yeah.
Yeah, the latent thing is training.
Yeah. Also, I think it's funny that no.
Pretty complex
Ah.
training stuff. Training
I know it
latents
was
using
the case,
train
but I feel
force.
like this kind of paper can be maybe done by Claude these days now.
Yeah, it feels Claudish to me, but it's still good, I think.
I mean, yeah, another thing is like the previous paper we got, there was a really bad paper once. I don't think that this one seems okay, unless
I feel like that
the
paper.
code. Assuming the code is at least right. Like I think this has
Yeah,
it's kind of meh. I don't think it's a great paper or anything, but I guess it's not actively misleading or anything. It's just kind of trying to look more novel
yeah.
than it is, and kind of
I feel
not
like
doing
this is
a
like a
lot of
buzzwordish paper. It
not
feels like they're
doing.
trying to add buzzwords into that paper.
I mean, yeah, that's not bad. I think like I would want them to do a lot more ablations and stuff as Fight said, but
Yeah.
Well, if you
it's
look at
interesting
it, they
that
actually
at least
referred
it gave
to
us the
the.
idea of trying you know changing the steering amount by how much it is different from the steering vector.
Yeah.
Yeah, they straight up like took the direction from like they literally like refer to the coconut latent reasoning paper. It's not a coconut steering method. Like I don't understand how the coconut's related here.
Yeah, that's. I wouldn't
That-
Or like I
that's
feel like the
if they
results
ask
are
Claude
not
to
fake.
to find related
Or-
things or something.
I feel like this is like a very heavily Claude assisted paper, and then Claude just added, and then like it's not 100%
hallucinated thing.
related.
Yeah.
It's like a Claude assisted
Yeah.
paper. It's like not like it's
But-
all Claude generated, but like Claude added stuff that clearly does not match what they're doing.
Anyway, I guess
But that seems to be the only mistake so far.
yeah. I mean, we will have to check their code. The fact that this is 3 and this is 0.3 is kind of sus to me. I wouldn't be surprised if they might up the.
And what
Like,
I
the
wish they also
baselines.
added. Yeah, I wish they also added no steering baseline.
Yeah, that's true.
Oh yeah, over here, this is the code. Yeah, so they just took the EOS token, they started taking the inputs, and then to get the steering vector, they just took the average across a few tokens.
I guess we could give the code to Code and ask it if there is if it can see any mistake.
Yeah.
The future of reviewing papers.
What?
Claude is
There was some paper recently that said like LLM reviews are more coherent than a lot of actual reviewers.
I
and stuff
mean,
like that.
yeah, that doesn't surprise me, but that's because the reviewers are usually pretty bad. Right? Like that's a very low bar. The LLMs have at least read your paper and know about the literature.
Yeah.
I think. Yeah. I also love about the little results because I mean, for example, when I publish my paper on on the ACL, right? The people who none of the people who review were actually Mech Interp people, because there is not that many Mech Interp people to review the Mech Interp papers yet that are doing reviews. So
Who knew?
and I mean, one of them clearly have no idea what he was talking about, like very hard, and we have to politely tell him he was just wrong. But the other were okay. The other one of them, I feel like he just skimmed it and said like, "Why didn't you add this thing?" And we added a thing, and that was it. And the other just said they like it, but like the way they were talking, it was like they hadn't seen Mech Interp papers before, and they really liked the idea. But yeah.
What is this?
What?
They just found good in file name and bad in file name. How do they make these files?
They probably just filter them with the.
They could have just done this while making the store vector py. Weird.
Anyway.
They could have done this in computes collect states. So why? Well, why do it this way? Let's see.
Maybe Claude did it.
Also.
Or like I could think of ways to like maybe like reduce make it faster.
Babel sent in the chat a thing with
nice. That's a nice Claude review.
With a Nature paper about automating with Claude. We should read this. It's so interesting.
Like Anthropic just really. This is from Jeff Kloon. Oh yeah, Jeff Kloon is working on this a lot. Is it with Claude?
I don't know.
Yeah, like I just AI scientist. This is their AI scientist paper. This is an interesting paper. I think it's not just Claude. Maybe it is. I don't know. But I just sent also like Anthropic just released automated element researchers that apparently are superhuman in some ways.
Where did you add it on the reading group channel? Okay.
Yeah, I sent it on the reading group. So this is another thing to read. I'm so like torn because like when I try to do this myself. I have to. I don't have the energy to review it all. Maybe I just need to gain that energy.
Oh, so they actually did get the steering correct and incorrect actually differently.
Oh.
Do you know what I think you answered this earlier, but do you know if it's actually right?
I'm looking at the code right now. I'm just like, this is not the standard like take average for good and bad though.
Do you know what the in your thought like baselines are?
Let's try to see.
I'd probably look at the. Let me think.
Let's ask Claude if he sees the reference. Deciphering. And can you elaborate, Realmbert? How is it different from the normal way?
Or like, when you read the paper for how they got the direction of like the expected correct and I guess they did not take the average. Like they took expected correct and like expected incorrect. Oh yeah, over here, like I guess I thought it was like they were taking like the whole data set and then taking the average and then like using that average difference to compute it. But it seems like instead they're doing this other thing where they're having an LLM judge on top of when it has the true answer. They have an LLM judge.
I wouldn't predict LLM judge.
Why add an LLM judge to like predict what is correct and not correct when you already have the true answer from the dataset?
Can you show me the LLM call? Reward model.
No, over here. Look, I'm highlighting it. I feel like I'm not.
Original input.
So like over here, you see collect states, right? You see collect states, and this collect states is used to calculate compute steering vector. Compute steering vector uses the difference between the good and bad vectors and then like I guess finds the mean between them. But if you look at collect states itself, like they're not necessarily taking one activation each. They're doing this.
So
They
example
extract,
true answer.
they extract the example like answer. And then I guess after they get the example answer, they ask an LLM, is this correct? Like, is this, I guess,
original
past?
generation.
So you see the example answer, right?
Output. Yes.
So this is the actual answer, right? And then like I guess like
Oh, because I think
they
I
use an
know
LLM
maybe why.
judge on top of it to judge if it's correct or not. I
Maybe
honestly
because I think maybe you know why. Maybe because usually you need the JSON formatting to be correct in order to automatically evaluate if it's correct or not, and this just sidesteps this issue. Like usually the LM judge is basically always correct. So this way you basically, I think this is a way to overcome the formatting problem.
you could have just fixed the formatting without making a whole LM judge. This feels redundant, but
yeah, but like if you have LM that's unreliable, which maybe was the case, then this
so
is
the
a way
LM
to
coded
fix it.
this and probably coded a judge to determine if it's correct or not instead of just looking at the data set to see if it's correct or not. Like this,
I
I feel
guess
like
it depends. Yeah,
because the
you
reward
get verification.
verification up here.
Mm-hmm.
It says
And
the
how does it
question
work?
solution.
Message inputs.
Oh wait. So wait. I was not paying
generate.
attention to that, but isn't it that if you output some text, you need to know if it's the correct answer, right? Like there
Yes.
is no nice way of doing that without an LLM.
I guess maybe you also wanna verify if the reasoning steps are correct, and if it's
Like,
not formalized and lean, then you cannot do it automatically, as far as I know.
I'll
This is
need
not
this.
just for the reasoning steps. This is just for the final answer emission, though. They're like
Okay.
5 and
Yeah,
5.
no,
Like,
but the
completely
final
different.
answer, if it's written in if it's written on normal on natural language, you need an LLM to check if it's correct. You can get the model to instead just write the answer as a number or something, make it output the class correct token or something. I don't know how the dataset looks like, but I
I feel
can.
like a fine-tuned model would you could just fine-tune the model to give the answer in that case and just
That
test it.
doesn't like even reliably if you do the like DeepSeek in their original GRP or reinforcement learning, they had to like give it reward for having correct JSON, etc. So and this models that they are using, the llama models, very small,
Like,
7B or something. I'm not surprised it doesn't follow.
How is the GSM?
So they see the correct answer from the example data set, and then they put this through they first generate a solution with the hidden state and the original output, and then it puts it through
I mean, okay,
and then
if
it,
they
and then
try
it
this,
sees
if the answer is
how
always
many
a number, you can just check the last example and do that. I don't know what. But maybe on the math.
yeah, and then also over here, if you look at the reward model, they check how many times, but then over here they check how many are, I guess, inside the verification values that are correct, and if it passes a threshold, they use it. But you're already finding
verifications.
Yeah, verifications. Like what? Why do you need the
how is there
verification
multiple?
sum?
Can you look at like how do you get multiple verifications?
Like the original, I don't, the original paper has to have, like the original dataset has to have some way of checking it, right? So it's confusing. So I guess it's confusing for me too. Like,
So they have load.
You need if you are making your own dataset, you might want to you do what.
So the correctness check asks the LM for a calculation answer completeness and understanding check at the same time. That's what they're doing.
Okay, so there's like multiple evaluations. I see.
Yeah,
I see.
but they then say if 2 of these pass or a certain amount of them pass, it's correct. But I don't think that's necessarily the best way to look at it.
Mm-hmm.
Who knows? Maybe the calculation is always correct, and this is just gonna this basically asking 4 ways it could be correct, with the threshold over here. Where's the threshold?
It just depends on how what the answer look like, what the output of the model and what it's supposed to be looks like.
Arg's good example would be, where is it? I don't see it. I don't see the good example number. Oh yeah, by default all 4 have to be true. Okay, that's good. At least that's good.
Yeah, that makes sense.
But then after they run the hidden state, they just like store the hidden state, and then afterwards they find the mean for the bad and good count. Why do you use .mean? You could just add the vector across each one and then divide it by the number correct, and that's like.
I guess this is just faster, and under the hood it does the same thing.
Well, .mean requires you to store every single vector though.
Okay.
This is same speed, but like you just spend more memory to do the same thing.
Well, it's more readable.
It's more readable. That's the only benefit. But like seriously, like why? Why make it like why?
Welcome to Python.
No. Like when I do Python, like you just like add it and then divide it, and then you save. You only store one vector the entire time instead of storing like n vectors.
Mm-hmm.
Right? Like think about it. You only need like averages. Just add sum and then divide it by like n. So you could just add the correct vector's hidden state and then divide by n afterwards instead of storing every single one and then just doing the exact same thing. You could just compute that while you're doing the forward passes.
Oh, I see. Well, yeah, it's a trade-off, readability and memory.
Well,
by the way, I noticed for some reason it like if you look at the alpha thing, for some reason it breaks. Like it's at 0.3 to 1, and then it's
what? What? That makes no sense.
Maybe just.
And why is the time bigger as well? Suddenly.
Did you see the GSM-8K dataset?
What? Yeah. How does different alphas have different times?
Did they like use some other GPU or something?
Like.
Probably the same.
That table is really weird. Like, what the fuck? Like, why would you make this table like? I guess you make it like the time. It's the same method of all of the times. You don't.
Yeah, you can see above. Once it's like 2 seconds, and then it's like 16 seconds. This is so weird. Yeah.
Oh look, like for example, like look at this one. Like, okay, so sure for the GSM 8K, like you could have like the single answer one. Let me get it. GSM 8K single answer. Oh yeah, Zen. Yeah, like depending on the GSM 8K version, like you literally have the answer as like literally one answer. Do you need a reward function to check that?
I guess it depends how reliably the LLMs are outputting the answer.
The LLM might just learn to like say.
Yeah, the issue. Yeah, like this is what
the reward model might just learn to say everything is correct. That might just be like the reward model. But I'm saying like you could just use like string and then probably find if it exists at the very end. That's probably a good way to see it.
Yeah, I guess you could do that. Yeah.
Because look, GSM 8K literally has one word answers. You could just check.
Yeah, it's a number.
Output.
You can check. Yeah, you can check the last number in the string.
And then,
yeah.
Look, look at this over engineering. Why reward model?
Things very Claude generated paper and code base, to be honest.
But you know what I'm saying, right? Like this is like over engineering to do something simple you could do with no error.
Yeah, Yeah, definitely. Like I wouldn't do this probably. If it's a data set that has just like answer one single number, like I would check for the last number in the output string.
Yeah, but that's for one of the datasets. The other dataset's this one. Sure, like
And the
maybe,
answers.
but like over here, like okay, maybe you might need the reward modeling to do this, but that's more of a formatting issue.
Yeah, this is the issue here. Definitely, because sometimes the LMs answer in LaTeX and sometimes they don't. And when you do reinforcement learning, you have to give it a reward for using LaTeX or not.
But like,
So
I honestly feel like this could just be solved without using a reward model. Like this feels very Claude generated for the code.
I guess you could also set for both LaTeX formatted and non-LaTeX formatted, I guess.
Yeah, but like, but yeah, but that's going to be more reliable than whatever this is. Like training a reward model to judge if it's correct or not. How do I know this
They
reward
didn't
model?
train, no. This is just how is the reward model created? Reward model. Is it import reward model from Hugging Face or something? What is the reward model object class? How do they get it? Go on top. Go on top.
I'm seeing it.
From rewards reward, import reward. So it's in the rewards reward file. Go in the rewards.py. Yes. And reward tokenizer type model. QDA.
Oh, model.
Is it the reward model from the data set? From the how do they use the benchmark? Maybe it's some official reward model.
This does not seem like a reward model that was trained by the dataset itself because there's no reward model for this specifically.
But
I'm saying like there's like issues that I have with it, like how it's implemented. Maybe like you could have done it simpler.
Model to use for reward prediction. Where do they initiate the reward model?
They initiated
see
over
what model
collect
they
states.
use.
You can clearly see they initiated in collect states.
Collect states. Reward model. Okay. And what do they do? Auto reward model. Model. What is the model? Model is from pre-trained. Model name or path. Args. So it's from the argument. Okay, so it's in the argument. Let's see how they use the library.
There's no default model path, so we don't know.
Oh yeah, so by default, the model is grading itself. Okay.
Yeah. But,
I see.
But you know what I'm saying, that the model is grading itself. Do you think this is a good way to assess it correctness?
I mean, if you don't steer it, like I would
You're
use it
steering the
automatically.
model
I'm
for
not sure why
correctness,
they.
but also having the model check itself.
I mean, yeah, it seems convoluted, but I think it works approximately, mostly.
Or
It
like,
seems
I
just
guess it's the equivalent
useless
of like
compute.
a 8th grader telling you what thinks they looks correct, and then another 8th grader, I guess, grades it. It's not actually correct.
They are
but, like,
they are usually they are pretty good, I think, at this kind of verification. But it seems complicated. Like, also another reason why I think this is a LM generated code base, which is fine, by the way. I think it's useful to use LMs to generate code base. Is all these parser add arguments.
Ideas from it, or
this is
the ideas of conditional steering is fine. It just the implementation is I don't buy the results fully with how like it's implemented with the reward function grading itself and stuff.
The parse argument function, every time you ask LLM to do any code base like this, they always do these arguments like this with the parse arguments function. I'm not. It's a pattern. That's all.
It's
hard to parse, right?
Previous generated paper, we are seeing the SOTA improvements on
that is basically this is basically how they get this is how they judge correctness.
I mean, I don't think it's probably okay, right? Like
I also think it's
that's
okay.
because in this case,
But
like
are they
the answer
steering the
is
model?
just some number. If the model has the correct answer, you are just using LLM as a way of taking some semantic text and extracting. Yeah, what the answer is this text saying it is, and does it match with the answer the response thing says it is, right?
I feel like this is gonna have a lot of false positives.
I mostly expect it's just going to be right, actually. If it's what I'm thinking of, I haven't read that. I don't know what this like exactly, but
I think instead of this code base, we could like take how you usually train reinforcement learning, where you specify how to use the reward, how to calculate the reward, the correctness, and just use that. And instead of doing reinforcement learning, you do steering vectors, basically.
also, I feel like this seems like replaceable with just get the model to answer the number at the end, like tell it on the prompt and get the.
Yeah, that like I thought at first that because they are using 8B llama models that are not RL tuned, that like by default they are pretty unreliable in terms of the output format. So this is like I thought this was like way how to sidestep this issue, but maybe it is the way how to sidestep.
Oh yeah, I guess that's probably it. I mean, I didn't think that makes sense. Like
Yeah, I'm just the only thing I'm taking away is the idea of conditional steering from this paper. Everything else I might not buy.
Like it
The
seems
conditional and the
coherent,
idea
everything.
of correct minus
The
incorrect.
the only thing that doesn't seem coherent is the coconut reference, and yeah, I guess this over engineering.
There's like random references to papers that like don't match the thing they're doing.
Do you see any other? I just see the coconut one. Otherwise, everything else.
COT?
seems
I don't see
years ago
COT
when I
ever
was-
implemented. Like I don't see their COT model explained. I feel like this person did not know which COT model they used because like it's not listed. The ARG model name path is not listed, but they didn't also put in the paper. So maybe Claude just put in a random COT model and it doesn't match the base model.
Interesting. Claude is
You
telling me
only
by
see the
COT they
instruct and
just
the
mean
non.
chain of thought
You only see the
prompting.
Quen, and then you see llama, and then the size changes, but you never actually see the exact COT model. I don't think.
Okay, so the chain of thought. Okay, so I think this is not a bad.
The chain of thought model is not included in the code base or the paper. So
No,
for all I
isn't the chain of thought is just the normal modeling, and they add let's think step by step to the prompt.
Yeah,
just
that's there's a
that's
reference. 10th reference, I think. Yeah. If you go to
Wait, so
page 4,
makes the model worse in this dataset.
Oh, okay, interesting.
With the first
This
prompt,
is maybe
with the JSON thing, it doesn't, but it doesn't. It's not much better.
And latent seek is better there. Also, why is it so much better on this dataset and so much different on this dataset? I'm so confused.
Well,
They
it's
are
probably
two just
because
this one is harder. I think the first one is harder. Than the second.
No.
Okay.
The Math 50 is the one that has the latex formatting.
Okay.
GSMA cake is literally just one answer, one number. So maybe
Why
there's some.
is latent seek? Why is latent seek worse on the easier ones and on the harder ones?
But it's the opposite for ALS. ALS does.
Yeah,
like
that is
the
weird.
math
probably
data
does better on
is
the harder
actual
one.
math. This is like high school problems.
I see. Okay.
Yeah, GSMA cake could be like a vibe coded problem from the reward model. Math A50 could be bought.
But
And also the trade-off is
okay,
interesting.
So the JSON thing seems to be that. Well, actually, no. Why is the model so bad with but it seems the model is really bad with the JSON prompt for some reason. Right?
I guess it's just not trained enough or something. Also, they're using old Llama models, I think. Yeah, Qwen 2.5, Llama 3.1. They're
you
relatively old by now.
You could
We have
see
better
that,
models.
like, it's better with the thing, but gating doesn't help at all for some reason.
Yeah, but it works on the other one a bit. But latent seek is just better. What is the SC again?
Also, yeah.
What is
Also,
the SC?
also, Claude also found us that this is SAS in that the model clearly can't solve the problem, right? It's just that for some reason
Did
it
you
breaks.
talk about the critiques and suspicions about the code to Claude as well? Give them the code base as well and explain the thing about how the reward model is used to judge itself.
Self-consistency.
Yeah.
I'm not using Claude to review the paper. Just just seeing this paper feels like the gut.
Yeah, the self-consistency thing seems to be the SC seems to be not be what I
This
said
feels like
before.
a paper
but
where they had a decent idea, but they just failed to execute on it because they trusted. They just Claude coded everything.
They Vibe researched it. This is the reason why I cannot trust all the Vibe research stuff, because then I look into it, I see these flaws, you know.
Okay, so the ideas are done by the human, but the model doesn't do it properly.
Yeah. Like, and then there's like Anthropic who's like, oh, we have automated safety researchers now. I'm like, how? That's not my experience.
With that, okay. Also, well, on the other hand, with that, is the Anthropic thing like the actual, like with Opus or with Mythos or whatever?
Yeah, that's correct. Also, this paper is how is it?
No, I'm asking.
And also, unlike normal people, like they actually have people to review it, like make sure it's not like deslopified, right? Over here, who's the one deslopifying this paper? Algoverse. Oh yeah, Algoverse is decent, but like Algoverse usually like upskills random people paid, and then the one person does the research. Mentees do stuff, but I don't know. I have no opinions. It's an Algoverse paper, of course.
Oh, I remember we talked about Algoverse before. Also, to answer a question, Victor, I don't know.
The last Algoverse paper we read was a Scratchpad one that we reviewed, and like the basic summary is they overpromised. It seems like a common pattern of the Algoverse papers. They overpromise.
Okay.
Like it's not bad completely, but like there's like cases where they overpromise and like just add buzzwords, and that's how it feels like for some of these Algoverse papers.
Yeah, I see why you had the prior before with the buzzwords.
But like but like I just noticed now it's Algoverse, and I'm like, oh, makes sense. All the Algoverse papers I've read so far, like they're not bad in the sense like they didn't do research. They're not like the slop in bottom tier. It's like they did research and then they added slop on top of it. That's basically it.
I mean, the paper, this is the only paper I could find that did math, correctness, incorrectness. No other paper I could find did this. Oh, steering vector, concretely.
Well, nobody needed to, and also how they implemented it feels contrived.
Let's do it properly. Let's use
I have
steering
no
vector
reason
library.
You have no reason to do it properly because, or I guess you could try to do it properly with your agent swarm and then make the same thing.
That's why I went out with my own brain and hands, because I don't trust. I have trust issues with. Also, this was done 6 months ago, and the agents got much better in the last 6 months. So, yeah, that's another aspect. And still not good enough for me to trust them.
I think we're done reading the paper. This turned into a paper roast. If it's one of those papers that we end up roasting.
Are you here, Victor, by the way?
Oh, yeah, sorry.
I think we're done reading the paper. I think we're at this point.
I'll stop the recording.
We're at the paper roast.
Yeah. By the way, I had the idea of